Hi students, we're going to look at solving rational equations, which also is going to talk a little bit about simplifying some rational expressions. Alright, so we've got to perform the operation. We're multiplying and express this in simplest form. First thing I always want to do is factor stuff. So we end up with x plus 9 and x minus 1. X minus 1 stays in the bottom. 4x squared, nothing to factor there. And then we got x plus 9 and x minus 8 on the bottom there. All right, I'm going to identify excluded values first. X cannot be 1, x cannot be negative 9, and x cannot be 8. Then I'm going to cancel some stuff out. I've got a plus 9 on top and the bottom. I've got a minus 1 on the top and the bottom, and then multiply straight across. We end up with 4x squared over x minus 8, and our problem is done. These are still in play and must be included in terms of anything that you do for me. Same thing, but now we're looking at dividing. I'm going to factor and divide set up in kind of the same step. I'm going to color code things to make it a little bit easier to follow. We get x plus 7 and x minus 4. 2x cubed. When we divide, we know that's the same thing as multiplying by its reciprocal. So x minus 3 is going to be on top. And I'm going to factor this guy to go on the bottom. We get x minus 3 and x minus 4. I'm going to take a look at my excluded values. I do have to think about that x cannot be a 3 from the beginning, even though we end up with that in the bottom, which makes that okay. I also have x cannot be 0, and x cannot be 4. We're going to cancel some stuff out. X minus 4 on the top and the bottom, x minus 3 on the top and the bottom, x plus 7 over 2x cubed with my excluded values is my answer. Ooh, this is ugly. We've got what we call a complex fraction. I'm going to do the denominator and the numerator separately and then kind of bring them back together. I know to combine fractions, I've got to find common denominators. I'm going to take the first one, x plus 4 over 5, and multiply it by the other denominator. And I got to do the same on the top and the bottom. Same thing here, I'm going to multiply by the other denominator. That gives us x squared plus 4x minus 5. And on the bottom, we've got a 5x. All right, same thing on the other one. I'm going to call this 1 over 1. Multiply that by x squared over x squared. And then we have common denominators. That's going to give us, do this one in blue, x squared minus 25 all over x squared. Okay, we know that fraction bars are really just dividing, so I'm going to write the numerator, x squared plus 4x minus 5 over 5x. Dividing is the same thing as multiplying by the reciprocal. We've got x squared over x squared minus 25. And now we're going to factor. Factoring on the left gives us x plus 5 and x minus 1 over 5x. Factoring on the left gives us x plus 5 and x minus 5. I've got to check for excluded values. From my final form, x cannot equal 0, negative 5, or 5. And looking back, there's nothing else that shows up on a denominator that we didn't cover. Now I'm going to cancel. I've got an x plus 5, an x, and an x that should be an x squared. So that now should just be an x. Okay. That leaves me with x times x minus 1 on top and 5 times x minus 5 on the bottom. at that point, we're done. We're going to do the same process that we just did twice, but now just dealing with this in terms of combining one fraction. To do this, I'm going to factor. So we've got 2x plus 7 over x minus 5. By the way, that tells us x cannot equal 5. 5, we don't factor. This guy is going to turn into x minus 5, x minus 5. You might notice that the only thing different in these two denominators is that this has 2 of those x minus 5 troublemakers. So we're going to multiply the fraction on the left by x minus 5 over x minus 5. Do some distribution, and that's going to end up giving us 2x squared plus 7x minus 10x minus 35 minus another 5, and that's all over x minus 5 times x minus 5. Just for funsies, let's see if any of these reduce any more. Minus 3x minus 40 I'm looking for things that multiply to negative 80 and add up to negative 3. Negative 1 and 80, negative 2 and 40, negative 3 doesn't work, negative 4 and 20, negative 5 and 16, negative 6 doesn't work, negative 7, negative 8 and 10. And I think we crossed that this is not going to factor based on any strategies that we have. So at this point, that combined with our excluded values, we are done. And then finally, we have to think about this in terms of using it to solve equations. This is just kind of an applied form of what we just did with as far as combining some like terms. Combining fractions and adding and subtracting. And what we're going to have to do here is to factor. Here we're going to have just an x times x plus 1. I'd like you to notice that both of these terms have an x plus 1, but they don't have an x. I've got to multiply both of those by an x. Okay, while I'm here, I'm also going to write x cannot be 0 and x cannot be negative 1. We always need those excluded values. All right, so we've got 3x over x times x plus 1. We've got an 8 over x times x plus 1. I'm going to just, no, I'm not going to do that. We'll do that separately. And then I've got 5x squared over x times x plus 1. Cool. Now that I have all denominators the same, technically what I'm doing is multiplying everything by that denominator. However, we usually just cross all three of those out. I'm going to bring everything to one side and leave us with 5x squared minus 3x plus 8 is equal to 0. This is going to be factorable. This might be factorable. We're looking for things that multiply. Ooh, this is going to be factorable because that was negative. So we're looking for things that multiply to negative 40 and add up to negative 3. That's going to be negative 8 and positive 5. So negative 5x squared minus 8x plus 5x plus 8 is equal to 0. I can take a negative x out of the first two, leave me with 5x plus 8, and then take a 1 out of the second two, leave me with a 5x plus 8. That gives me negative x plus 1, and 5x plus 8 equals 0. That tells me that x equals 1 and x equals -8/5. I do have to check my excluded values to make sure that those do not affect either of those, and they don't. Those are our two answers to this problem. All right, we're going to do the same thing. This one is already factored for us, nothing to factor. That's really nice. Each of these has an x minus 1, so they need an x plus 5. And my middle friend needs an x minus 1 because that's what it does not have. We know that denominators all being the same, we're going to multiply by them all and basically get rid of them. I do need to identify x cannot be -5 and x cannot be +1. We end up with 3x plus 15, plus, we got to do some distribution here, 2x squared plus 3x minus 2x minus 3. And that's equal to 3x squared plus 15x. I'm going to bring everything onto the right side, and that leaves us 3x squared minus 2x is going to be x squared. 15x, that's plus 1x, minus an x is going to be 14x, minus 3x is going to be an 11x. And then we have 15 minus 3 is 12. That gives us x minus 12 and x plus 1 equals 0. X equals 12 and x equals -1. Neither of which are excluded values, so we are okay.